The perimeter is going to be something where we are doing addition. It's going to be on a closed figure, and the figures have to have straight lines as edges, no curved. So it is the sum, where that means you're going to be adding, of the side lengths of a closed plane figure. For example, if I had a rectangle and the length of that was 18 and the width was 6, that would be 18 and 6 as well. So we would do 18 plus 18 plus 6 plus 6, and the perimeter would be 48 units. An area of a figure has a very distinct definition. It's going to be the number of non-overlapping unit squares. So let me write that. The number of non-overlapping unit squares of a given size. So that given size could be inches, meters, miles, whatever it is, that unit that we're measuring. And that will exactly cover the interior of a plane figure. So if I had a rectangle that looked like this, and this was a unit square, I'd see how many of them I could fit into this closed plane figure of the rectangle. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This would be 12 square units. When we're talking about the base and the height of a triangle, we are doing them together because they're defined by each other's location. So the base can be any side of a triangle. So if you pick one side to be your base, then you're going to find your height of that triangle. This height, h, is a segment from the vertex that forms a right angle right, 90 degrees, with the line containing the base. So if I have a right triangle, I would use one of those legs as a base because the other leg would be the height. Now, if it's not a right triangle, now I could use any one of these, but I'm going to use this one. This bottom one here is my base, and then I'd have to draw in a perpendicular line from that base to the opposite corner of the triangle, and that would be my height. Now that height doesn't have to be inside the triangle either. If I have something like this triangle and I make this the base, I could extend that base and from this vertex come down and make a right angle, and that would be the height outside of the triangle. Now we're going to look at some vocabulary words that deal with dimensions of circles. First one is diameter. So keep in mind that we are talking about circles. Pretend that's beautiful. So a diameter is a segment, so it has endpoints, that passes through the center and the center is of a circle. And whose endpoints are on the circle. So we have a center, and we're going to pass through there. So the endpoints are on the circle, and it's the length of that segment is the diameter. When we're looking at the radius of a circle, once again, we'll be looking at a circle. So let me sketch a circle here. And this is going to be, once again, it's a distance just like the diameter. So the distance or length from the center of the circle to any point on the circle. So if I have a center here to a point on the circle, this length would be the radius. And the radius is equal to 1/2 of the diameter. Or you could say the diameter is twice the size of the radius. The circumference also deals with circles, so let's draw our little circle here. With the center. And the circumference is the distance or length around a circle, similar to a perimeter of a figure that uses straight lines. So if I were to take a piece of string and lay it all around the edge of the circle and then straighten that all out, that would be the length or the distance that it takes to go all the way around the circle. Pi, that's a Greek letter that looks like this. It's spelled P-I and it's said pi, but it's a symbol for an actual number that we use in math. And that number is derived from a circle, and it is the ratio of the circumference to the diameter. So if you have a circle and you have a radius, it would be the circumference divided by the radius. Now that is a constant number. It is always the same, and we often use an abbreviation or an approximation of 3.14. Now when I want you to do calculations, I'm going to have you use the pi button, so you're going to look for that button on your calculator because it carries it out to further decimals. So we're going to take a look at some formulas now. This one, we're going to look at two formulas for a rectangle, the perimeter and the area. So let's draw ourselves a rectangle. And we don't know the measure, but we're going to say that this is the length and this is the width. And the opposite sides are going to be equal. So we've had a rectangle drawn here. So the perimeter, we're going to abbreviate that as P, is going to be 2 times the length plus 2 times the width. The area is going to be the length times the width. Now let's take a look at the perimeter and area of a square. Now a square is just a special rectangle because the length and the width are the same size. So every side is the same. So we'll call those S. So a perimeter, since we're going to add up side plus side plus side plus side, the perimeter of a square is 4 times the side because it has 4 sides. And the area, instead of being side times or length times width, they're both the same, so they're both sides. We're going to call it side times side, or side squared. And that's where we call it squared because of the shape of the square. And then we have the perimeter and the area of a triangle. So let's draw our triangle on the back of our card, and let's make it be something that's not a right triangle. And we're going to have a height here, and let's label the sides A, B, and C. And we'll use the B side as the base as well. So the area, or the perimeter, is just the addition of all the sides. So it's going to be A plus B plus C. The area is going to be 1/2 times the length of the base times the height, the length of the height. Or you could also write it as base times height divided by 2. And now we get to the circumference and the area of a circle. So let's draw ourselves a circle and put some parts on it. So we've got a center, and we've got a diameter, and we're going to have a radius. Now the circumference and the radius also use that real number, irrational number, pi. That's why we had a definition for it. So the circumference, let's label it uppercase C, is going to be given as pi times the diameter, or 2 pi r, because 2 times r would be the diameter. The area is going to be given as pi times the radius squared, or pi r squared.